Alright, chapter 2.4, lines and angles, proofs of perpendicular lines. Interesting. Alright, so vocabulary. Two lines are parallel if they are coplanar, meaning they're in the same plane and they do not intersect. Very similar to railroad tracks and railroad ties. They are in the same plane and they do not cross. New ones. Two lines are skew if they are not coplanar and do not intersect. Okay, this is new for us. We're thinking in three-dimensional space. That means they're on different walls, or they're on the ceiling and on the floor, or something like that. Here's a great example of skew lines. Notice the yellow part right here? They're not in the same plane. One's going on this way and one's going this way. They still never touch, but they're not in the same plane. Here's another great example of skew lines. This pole right here and the wire never touch each other, but they're not necessarily parallel because they're in different planes. Alright, next one. Two planes are parallel if they don't intersect. The green one and the little shadow right here, they never touch each other, and they're also two-dimensional shapes. That's like two walls of a hallway. Right here, you see those walls, the ceiling and the floor, they never touch. They're both planes, but they never touch. Now, two lines are called oblique if they are coplanar and intersect, but are not perpendicular. So if we just have two random lines that intersect, we call them oblique. Otherwise, they have to be 90 degrees to be perpendicular. Transversals. Transversals are very specific. It's a line that intersects two or more coplanar lines at different points. Right here, this red line. It cuts the two blue lines at different places. Now the two blue lines are red lines. We don't have specific names for them, but the red one that cuts them across is called the transversal. Now if we look at corresponding angles, we've talked about this before, but that means that 1 and 5, they're in the same place. They occupy the same position on the different blue lines. Okay, if we talk about alternate exterior, then they're outside of the two lines being cut, and they're on opposite sides of the transversal. So 1 and 7 is a great example of an alternate exterior angle. Here's alternate interior. You can call them alt-int, you can call them AIA. There's lots of different abbreviations you can use for these. Use them. Don't have to write down alternate interior angles every time. Here's 2 and 8. They're on the inside, they're on the interior of the two lines, and they are on alternate sides of the transversal. Consecutive. Okay. They're interior, and they're consecutive. It's one after the other. They're not on opposite sides. I've called these same side interiors before as well. It's up to you on how you want to verbalize it, but I'm going to be expecting consecutive interiors on the test. So, same side of the transversal. See how 2 and 5? They're on the same side of the red line, and they're in between. Alright, now, the names. We're going to name two lines. This is example 2.22. Name the two lines in the transversal. So the two lines in this situation are C and D. Oh, let's see, I'm supposed to write this out. I don't have my stylus out. That's terrible. So I would write in here, I'd say the line is C. Uh-oh. Gotta pull up my pen. C and B, and the transversal is B. You see how that works? CDB. Next one here, we got 3 and 11. The two lines that we're talking about are A and B, and the transversal that cuts them is right here. It's that D line right there. Let's say D is the transversal. Oh, 10 and 11. These are consecutive interior angles, and the transversal has to be A, and the two lines are the red ones and the green ones, so it's going to be C and D. You see that? Now, 9 and 6. Okay. Alternate interior angles, and A and B are my lines, and C is my transversal. It's cutting it right down the middle. Ooh, again. Alternate interior, but this time it's B and A are the lines, and the transversal is D. Right. Okay, I just heard my voice for a little bit, and it seems really loud and raspy. I'm going to try and figure out how to fix that. Here's your angle relationships. We have it on the little cheat sheet. You won't have it, you'll have it on the test, but you won't have any notes you've written on there. So take notes about what these mean on your paper, and hopefully we'll remember for the test. But that is going to be there for you. Right here, essential question number 1. B and B, what type of angle pair are they? D and D, what are those? A and A and C, what are those four angle pairs? B is corresponding, A is alternate exterior, C is alternate interior, and D is consecutive interior angles. There we go. If you're positive, you need to. I'm going on. 5, 6, and 8 are all about recognizing the four angle relationships. Good luck with those. Perpendicular postulate. If there's a line on the point, not on the line, then there's exactly one line through that point perpendicular to the given line. So this helps us find perpendicular lines, and there's only one of them that exists, so that's going to help us if we're trying to prove different aspects of lines and intersections. Parallel postulate, same thing, but if there's a point not on a line, then there's only one line that goes through that point that is parallel to the given line. Alright, right here. Two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So right here, two lines intersect, G and H intersect, and they form congruent angles, which means this is equal to this. Then both of those values have to be 90 degrees, which is why we call them perpendicular. Okay, so two lines intersect to form, if I have one 90-degree angle, then I actually have four 90-degree angles when I intersect them like that. That's basically what this is saying. Alright, two-column proof. Most formal type of proof. It lists the numbers of statements on the left column and the reasons on the right. We've talked about this before, but I want you to see an example of one right here. Angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 3. So this is given to us, look where the given goes. Angle 1 and angle 3 add to 180, that's the definition of supplementary lines. 2 is supplementary to 3, that was given to us. 2 plus 3 equals 180, that gives us definition of supplementary lines. Now, this one is where it gets tricky. Measure of angle 1 plus measure of angle 3 plus measure of angle equals measure of angle 2 plus measure of angle 3. This comes from the transitive property. Notice how both of these are equal to 180? Well, that means that I can set them equal to each other through the transitive property. Alright, so now we have measure of angle 1 is equal to measure of angle 2 by the subtraction property of equality. I just subtract measure of angle 1 and measure of angle, or both of those 3's off from each other, and they go away. So now the last answer right here, number 7, the slot that goes right there. Any ideas? Yeah. I told you the proof statement always goes at the very last bottom left corner. That's where your proof statement goes. Okay, paragraph proof. That's where we write it out in a big long paragraph. Notice how each sentence is basically a step in the column proof, but instead we're doing it as full sentences. Okay? And I like how it ends here with, we can conclude then that J is perpendicular to K. That's the difference. The paragraph makes sure out as full sentences. And usually they are in the form of if-then statements, or conditional statements like we talked about. Right here, there's your last reason. Notice how it says perpendicular lines and then it gives the final reason. That'll be important. Flowchart proofs. This is a different kind of proof. We have here the starting point. Those are the two pieces of given information, which leads us to these two conclusions, and it's because of the definition of supplementary lines. They then combine to become one statement of the transitive property and one statement because of the subtraction property of equality, and it flows into the very last statement. Okay? So these are flowcharts. Be familiar with all three types of proofs. I may ask you for a paragraph proof. I may ask you for a flowchart proof. But just they all stem off of the same concept as the two-column proof. Now that you know the three types of proofs, which do you prefer and why? Take a moment to think about that. Pause the video, but I'm going on. 2.6, use of linear pairs and vertical angles to use to find the measure of each angle in the following diagram. So if 5 equals 38 and 4 equals 133, what does 8 equal? Oh, we can do this. That seemed kind of awesome. We use the linear pair postulate, and we say it's 142. 8 is vertical to it, so we say that's equal, and we say 7 is vertical to 142, so we can solve that one fairly easily. Now on the left-hand side, the 133, if we do that same linear pair postulate, we can say that equals 47. And we can say vertical angles fill in the blank, and we get 47 and 133. So I just given two pieces of information, I found all the other information. Example 2.27. If those two lines are perpendicular, BF and AE, the measure of BOC is x, and the measure of GOH is y. So right here we've got y, and right here we've got x. Okay? Express the measure of the angles in terms of x, y, or both. Describe each step. This will help you with problem 20 on the homework. Alright, so I got those two are equal to each other because they're vertical angles. I've got these two are equal to each other because they're vertical angles. Don't forget to describe each step. Now this next one says that COF is our first angle. We can measure this as the green line right here all the way across, right? That's 180 degrees. But we don't want the full 180, we just want to come backwards to C, which means we're going to say 180 minus the value of this x right here. We're going to take it back. Alright, now the next angle is DOG. Here we have this whole thing is 180 degrees, right? We've got 180 degrees minus y. It will give us that angle. The next value, BOD, right here, BOD, well that's nice, it's just x plus y. Makes up that whole piece. That's part of the angle addition postulate. Next angle looks for is AH. Ooh, interesting. If I know that AOH is what I'm looking for, and I've got y and x here, but I also know that these are perpendicular lines, which means this whole thing here is 90. I'm going to do 90 minus x minus y, and that will leave me with what's left over. This whole thing is 90 minus x minus y. That leaves me with what's left over, is what I want. So, that's pretty cool. 2.28, which will help you with 16 through 19. We'll start here with some given information and a diagram with some given information. So BEC is perpendicular. See, BE is perpendicular to AC. Okay, so I got 90 degrees. That's given to me. ABE is 90 degrees. Well, that's just the definition of perpendicular lines. ABD equals 6. DBE equals 3x plus 9. Again, that's given to me. ABE, right here, ABE, the whole thing, equals ABD plus DBE. Well, that's part of the angle addition postulate. So I would say angle addition postulate. Now, 90 degrees is equal to 6x plus 3x plus 9. That's the transitive and substitution. I use the transitive property to replace and the substitution to plug it in. So I combine my terms for my next step, and then I solve for x to get it by itself. So I use the subtraction property of equality. I divide by 9 to get the division property of equality, and there's my proof worked out completely. Hopefully you guys can recreate that on the homework, or you'll be able to see it as an example of how to just fill in the blanks. You've been doing this in your notes the whole time, so it shouldn't be too hard. If you need more help, or if you'd like to come in and talk to me about it, feel free to come on in. Summarize what you've learned in this lesson about, we've learned about 4 different angle pairs. I'm sorry the microphone's so bad. I'm going to try and do some work on fixing the microphone. It sounds really crappy. But we learned about corresponding angles, alternative exterior angles, alternative interior angles, and consecutive interior angles. Please know those 4 very, very well. Memorize them completely and do all your notes and your homework and get everything done and turned in as soon as you can. Thanks. Hope this helped.